If you are new to the channel, then subscribe the channel and press the bell icon for further notification.
Okay student, welcome you all to this new lecture in basic level where we are solving previous year Tripura University questions on method of differentiation. So in this lecture we will be solving question number 1, 2 and then 3. Okay, then let's try to solve these 3 questions. So in question number what is asked, if y is equal to this, then find the value of second derivative d square by dx square. So you have to do differentiation 2 times. So first question, y is equal to log, I am not writing base. If I am not writing base, then you think that it is e. So if you take dy dx, what is differentiation of, so it is d dx of, for first one I am writing step by step so that you understand this one, x square. So log x square, you can bring these two in front also, but still you can do it in chain rule also. The outside is x square, or you bring it this side, because log x square, property of log is 2 log x. You can do it in this way also. So it is differentiation of 2 log x. So 2 is constant outside, differentiation of log x is 1 by x. So this is your first derivative. Now they are asking you to go for second derivative. So if you do it one more time, that means they are asking to do differentiation of 2 by x. So 2 is constant, d dx of x is 1 by x is x to the power minus 1. So what is the formula of x to the power minus 1? Minus 1 x to the power n minus 1. So it is actually minus 2 divided by x square. So you remember this one, 1 by x is minus 1 by x square. 2 is coming because here 2 is there. So after you do some differentiation, it should be easy for you. You should understand directly. Now if you come to question number 2, if x to the power y is equal to this, then prove that something of this one. Now you can see these are all in the head of x. Y is on the head of x. This is already exponential, okay. But here you can see one function is above another function. So first you have to bring it to your earth or your level. Then you could do differentiation. Then you can find dy dx. So for that you need to take logarithm. So that is logarithm differentiation. So this is given x to the power y e to the power x minus y. You will take log both side. So if you take log x to the power y is equal to log e to the power xy, which will implies y will come in front, y log x, and log e to the base e, this will come format in the front, and e to the base e is 1, so it is x minus y. Now you can take differentiation in both sides. You can write differentiating with respect to x. You can write these languages, or no need also if you write it in this format, d dx of x minus y. So if you do this one, differentiation of this one, first y constant, differentiation of log x is 1 by x, then first log x is constant, differentiation of y is dy dx, and d dx of 1 minus dy dx. Now next job what I have to do in logarithm differentiation, you have to collect all the dy dx in one side. So if you bring your dy dx this side, so it will be log x, and it will be plus 1, and here it will be 1 minus y by x, which will implies dy dx will be equal to, if you do LCM here, x minus y, and it will be log x plus 1. Now because you have to prove this one, otherwise it will be the correct answer, but they are asking to prove, they are asking to bring something of this format, log x. Now you can bring this one, you can see x minus y equal to y log x, because you have to bring log x, so that's why I am putting, you can say from 1 I am putting, so dy dx is equal to from 1. So what I am doing, in place of x minus 1 I am putting y log x divided by x, and here it is log x plus log 1, I am writing log e to the base e, because why? Because they have given a log e into x format. So it will be y log x, and denominator is x, and it is log a into b is log a plus b, log a into b. I am not writing base, you can think nothing is there, that means b. So this is log a plus log b, log x plus log e, so log ex. Now the thing what is left here is, you can see it is log x is there, log ex is there, but y by x is not there, so you have to remove this y by x. So to remove this y by x, you have to come to this one. How to come to this value? So from 1, you can check, write 1 again, from 1, y log x is equal to x minus y. So if you divide it by x, so y by x log x is equal to 1 minus y by x. You bring y by x one side, so that is 1 plus log x is equal to 1. So you write 1 by y by x. So you know what is 1 plus log x, you can write it, you can put it there also. Okay, therefore now dy dx is equal to, this you can give 2. Then instead of y by x, now you put it there. This is y by x is there, instead of y by x, what will be your y by x? 1 by 1 plus log x. This is actually of 2. So instead of y by x, you put this one, 1 by log x is already there, 1 plus log x into log ex. This one you have already seen, we can make it log ex using this one. So you can write it log x divided by log Ex whole square. So that is proved. Because it is proved, proof is there. So for proof you have to see where substitution you can do. That is required, because otherwise if they ask you simple differentiation, then that is my answer, that is done. But because they are asking to prove, that's why you have to see, every time you have to see what value you should put so that it should come like this. If y is equal to this, then show that this sine 2 sine inverse x. Then you have to show, here you have to think out, because y2 means second derivative. What is the meaning of y2? y1 means first derivative. You can write it y dash or y1, all meaning is same. If you write y1, then also means it is first derivative. So you have to go to second derivative and you have to prove this one. So for doing this one, after doing every step, you have to think. You don't go for directly second derivative, because then it will not solve. It will not come, because it is proof type. So you have to be very careful after every step. So if you do first derivative, you are writing y1. y1 means differentiation of this one. So if you do differentiation, what is the outer one is this one, inside is this one. Outer one is sine differentiation is cos. Then differentiation of this one 2 constant, sine inverse differentiation 1 by under root 1 minus x square. Now you can see with 1 minus x square is with 1 y2. So you take this one that side, root 1 minus x square y1, and then 2 cos 2 sine inverse x. Then you go for second derivative. Don't do it from here. You bring it this side, then you do derivative, because otherwise if you do start differentiation of this one, this will take longer one and it will not come also, because you have 1 plus x square with this one. So it's better if you keep it like this. So now if you do differentiation again, differentiating with respect to, you can write this line with respect to x. Then differentiation of this one, first this is constant. Differentiation of y1 is y2, because you are differentiating y1, you will get second derivative. Plus y1 constant, differentiation of this one. Now those who know differentiation of root is 1 by 2 root x, you can try also. d dx of, I am doing it here, 1 by, suppose root x. So it is 1 by 2 root x. How? Because it is half x to the power half minus 1. Half x to the power half minus 1. So x to the power minus 1 means 1 by root. So remember this one. Root is 1 by 2 root 1 minus x square. This is the differentiation of root, outer one. Then inside one you have to do. 1 is 0, 2x is minus 2. And this is differentiation of this one, 2 constant. So sine, cos differentiation is minus sine. So I can write minus sine into, again product rule. First you have done this one, then you have to go to this one. 2 sine inverse is 1 by under root 1 minus x square. Now you can multiply it to 1 minus x square both sides, under root 1 minus x square. So this will be 1 minus x square y2, and this will be 2 you can get cancelled. So it will be minus xy1, and you are multiplying by root 1 minus x square. So this become this, and this cancelled out, and here it will be minus 2 into, instead of this one you can write the original y back again. So minus 2y and into 2. So you can see now it is proved. So the idea is, after first differentiation you have to be careful, don't directly go to second derivative, just bring these to that side, then you differentiate, otherwise it will never come. So it is proved.
If you like the video, then press the like button and please give your valuable comments in the comment section.